In this session, we will be dealing with the forward markets and contracts, especially the computational elements of the forward markets. So, from that dimension, we are looking at a few types of instruments. One being, how do I look at the forwards on non-dividend paying stocks. We would also look at equity forwards, means the forwards on equity contracts, probably where dividend plays a role, and also we will look at the contracts on equity indexes. Similarly, we would look out for fixed income forwards, forwards on fixed income securities, again where coupon is involved, and similarly we would look at the forward rate agreements, FRAs. We would also focus on the currency forwards, the forward rates or forward agreements on exchange rates. So these are the 5 major categories of forward contracts we will look at, and finally we would also be focusing on what is the counterparty risk that is involved in the forward contracts. So with that as the base, we get started into it. We'll take up some numerical examples wherever possible to get into this pricing aspect. So whenever we talk about any of these contracts, we are focusing on 2 dimensions. One is the price of the forward contract, which is otherwise called as no arbitrage price. Right, we are talking about the price of the forward contract, and 2, we will talk about the value. Any forward contract, it could be on equity, it could be on a bond, or it could be on an FRA, whatever it is, anything we are trying to compute, any forward contract we are planning to look at. 1, we have a price to it, 2, we have a value. Price is determined at the time of entry into the contract, right, which is a kind of a mutually agreed upon price between both the parties, or probably one party is willing to pay this to get the delivery from the other party. All these are the meanings of the price, which is decided on the day of entry into the contract. So in a regular forward contract where there are no dividends or no cash flows intermediately, we price those kind of forwards as the S0, which is the current market price, into 1 plus R to the power T, where R is we treat as the risk-free rate of return. So any case of no arbitrage forward pricing, we take the spot price into 1 plus R risk-free rate of return to the power whatever is the time to maturity. This is the typical simpler form of the forward contract price. And when we talk about the value, we can talk about the value either at the initiation of the contract or somewhere. So let's say if I am having a 90-day forward contract, right, what is the price as on this day is what is the pricing. And when I am talking about the value, I can decide the value of the contract either here or probably somewhere after the contract got initiated but before the expiry of the contract, or on the maturity. Remember one thing, wherever the question is about value, we will find out the value as the spot price, which means on that day whatever is the price, minus the present value of the forward price. Forward price is the price that has been contracted by both the parties on the initiation day of the contract, right? In most of the cases we will find that at initiation the value of the contract is 0 to both the parties, because no party want to make any additional payment on day 0 to the other party, except in case of off market forwards. Probably off market forward is something which I would be looking as one party having an advantage over the other party on the day of entry into the contract itself, which means on the day of entry into the contract this equation does not hold true. Probably F is either more than this or F is less than this. So that is the scenario where we call them as off market, because the forward price is not reflecting the no arbitrage price based on a risk-free rate of return. So those kind of forwards are called off-market forwards, where one party has an advantage on the day of entry of the contract itself compared to the other party. And in those kind of contracts we'll see that one party makes a payment to the other party, whereas in all other cases at the initiation we find that the value of the contract is 0, which is nothing but the spot price minus the present value of the forward price. But any time down the lane we talk about the value of the forward as the spot price on that particular day minus the present value of the forward price which has been contracted. So this kind of a definition is what we call as the value to the long position, and in case I need to find out the value to the short position, I take the negative of that, which will give me the value to the short position. Just let's take a couple of numericals to get a clarity on this aspect. Compute a no arbitrage 120-day forward contract price on a non-dividend paying stock. So this kind of formula S naught into 1 plus R to the power T is applicable only when it is a very simple underlying security where no dividends or cash, any other intermediate cash flows are involved. So no arbitrage 120-day forward contract, which means the expiry date of this forward contract is after 120 days, currently selling at 300 bucks. So the spot price is 300 and the risk free rate is 8%. So what do I get? The no arbitrage forward contract price is nothing but 300 into 1.08 to the power T, 120 days, probably because this 8% is annual. I will take this as to the power 120 by 365. So this is how we get the no arbitrage forward price on this kind of a security. So going back into the spreadsheet to compute the same, I will get the forward price as 300 into 1.08 to the power 120 by 365, which will come out as 307.69, right? I am getting it as 307.69. So that is the no arbitrage forward price. 307.69 is the no arbitrage forward price in this kind of a deal. Now, how am I looking at the value? If the spot price of the stock after 1 month, so basically on this day we have entered into the forward contract where the forward will be expiring 120 days from today. Now what are we saying? Spot price of the stock after 1 month. So we have moved 1 month into the contract. On this day the spot price is 305, which means we still have 90 days for the maturity of this particular contract. Now this is where I want to find out the value to the long and short positions. So if the question is about the value, as I said, spot price minus present value of the forward price. The forward price is 307.69 divided by 1.08 to the power 90 by 365, because 90 more days are left to maturity. This is how I would be working it out. So probably if I want to find out the value, I am taking it as 305 minus 307 divided by 1.08 to the power 90 by 365. So this is working out to a positive 3.1. So which is working out to 3.1, which is a positive value. So a positive value is, it means that for the long there is a benefit. The long is positive by 3 rupees, 3.1 rupees. So long is at a benefit of 3.1, whereas the short is at a loss of 3.1. So for the short we'll say that the position is minus 3.1, for the long it is 3.1. So this is how we will try to solve the pricing as well as the valuation value of a plain vanilla instrument where there are no cash flows involved. If I have to find out the forward price and value, I would go ahead with this kind of an approach. This is one model we have to be comfortable with. Then the next set I would like to look at here is the forward contract on any equity security which may pay a dividend. If there is a dividend on an equity security, or if there are a series of dividends on an equity security, one or more, how do I get into finding out the no arbitrage forward price on that, as well as the value of the forward contract somewhere down the lane? For that, wherever any dividend, here we talk about two different cases. One is the scenario of discrete dividends, the other is the scenario of continuous dividends. Mostly for stocks, our focus is with respect to the discrete dividend, because we know that this stock pays the dividend probably annually once or twice in a particular month or something like that. Whereas when we are talking about index, we generally consider continuous dividend, for the simple reason that the index may contain 50 stocks and each stock can give a dividend on its own day. So literally it looks like more or less every day or every alternate day or every week we are getting some dividends or the other. So that's the reason when we are talking about index, we always talk about the continuous dividend yield. Alright, whatever is the case, if we are talking about the stock, first of all, when we are doing the pricing, let's say the current price of the stock is S0. What you will do is to compute the forward price, first we subtract the present value of the future dividends, which means you adjust the current spot price. You adjust the current spot price by subtracting the present value of the future dividends from the current spot price, and after that do 1 plus r to the power t, especially if the dividends are discrete in nature. If the dividends are continuous, take the current spot price and take it as e power r minus d into t. So whatever is the continuous dividend yield, take it into the exponent e power r minus d into t. So this will give you the no arbitrage forward price in case of equity securities. Right? So this should be the contract. So whenever we talk about the price, this should be the contracted price between the long and the short position in case both of them have to have a value of 0 on the day of initiation of the contract, or probably in order to make sure that no party is at an advantage or a disadvantage on the day of entry into the contract. So that is the way we do the pricing for equity forwards. And again, whenever we are talking about the value, the same logic, the spot price minus the present value of the forward price. But the only thing is, the spot price has to be adjusted with whatever is the present value of the dividends that are outstanding still during the maturity of the contract. Whatever are the dividends that are still expected to be received and they are not yet reflected into the price, that portion of the dividends need to be subtracted from the spot price, and after that we subtract the present value of the forward price to find the value to the long, and the negative of that will go as the value to the short. And in case we are talking about continuous dividend scenario, yes, you have to adjust the spot price, but the adjusting of the spot price is nothing but I divide it by e to the power of dt. Means the dividend that are still expected to come within the maturity period. So the spot is adjusted by dividing it by e to the power of dt. After that we are doing the present value of the forward. Whatever is the forward price, you divide it by e to the power of rt. This would be the value in case of index forwards on an index where there is a continuous dividend yield. So you can remember them either as formulas or basically as a logic. If you remember, it becomes more easy while doing any kind of modelings or probably any kind of a requirement can be captured quite comfortably once the concept is understood. Let's pick up a couple of numericals on the same to understand this concept more comfortable. Yeah, calculate the 120-day no arbitrage forward price. So this forward contract is going to expire in 120 days on an equity security whose current price is 120. So S0 is 120. Expected to pay a dividend of 5 30 days from now. Okay, so I need to subtract the present value of dividends. So 5 is going to be paid 30 days from now, 8 is going to be paid 110 days from now, and 3 is going to be paid 180 days from now. So if I look at the current spot price, right, the current spot price is 120. So the dividends wise, 5 is going to be paid 30 days from now, 8 is going to be paid 110 days from now, and 3 is going to be paid 180 days from now. Now we know that this contract is only for 120 days. So I need to first look out for adjusting the spot price with the present value of the dividends, but consider only those dividends which are expected to come during the period of the forward contract itself, not after the expiry of the forward contract. So basically I don't need to consider this to adjust the spot price. So how do I adjust this? So I'll find out the present value of these two things under the assumption of risk-free rate of 8%. So this by 1 plus R. 1 plus R is nothing but 8%, 1.08 to the power 30 by 365. So this is going to be the present value of the dividend that I am going to receive after 30 days. Similarly, this is going to be the present value of the dividend that I am going to receive after 110 days. 110 by 365. Right? So it is coming out, this I am not bothered, though I am going to receive a dividend of 3 after 180 days. Because this is going into the expiry period, I am not bothered about finding the present value of this. So I am adjusting. So adjusted spot price for me is nothing but the current spot price minus this. So this is my adjusted spot price. So the forward price will come out as adjusted spot price into 1 plus R 1.08 to the power 120 by 365, because the forward contract is for a period of 120 days. So this is coming out that the forward contract price for this contract is 109.96. So the no arbitrage forward contract price in this case has to be 109.96, and remember that this is lesser than the current spot price also, especially if the dividends are more. We can even look at this scenario of the forward price being lesser than the spot price also. So this is going to be my no arbitrage forward price on this equity security. Now the next part is compute the value after 60 days into the contract. Okay, so to compute the value, I am talking about 60 days into the contract, which means only 60 more days left for the expiration. So 60 days into the contract, and we are talking about the spot price on that day is 128. So 128, first of all, I have to adjust with the present value of the dividends, whatever are expected to come within the next 60 days. And after that, I'll put forward price, the present value of the forward price, 1 plus R to the power T. So how do I adjust the present value of the, the spot price? So again, adjusting the spot price is nothing but whatever is the spot price minus present value of the dividend. The dividend of 5 is already given, because it is given only after 30 days, but we have crossed 60 days, which means that 5 would have already been declared. But this 8 is still to be declared, but it will be done only within the next 50 days. So if I am finding out the present value, I will do it as this divided by 1.08 to the power 50 by 365, because only 50 more days are there for the second dividend to be given, and the third dividend is of no use because it is after the expiry of the forward contract. So the adjusted spot price is going to be this much. So when I am talking about the value, we are more talking about the adjusted spot minus the present value of the forward. This divided by 1.08 to the power, we have 60 more days to maturity. 60 by 365. This is giving me that the value is 11.5, which means for the long the benefit is going to be 11.5, and for the short the loss is going to be 11.5. This is how we will be computing the price as well as the value on this equity forward contract. The same logic can be extended to a bond forward also, or a fixed income forward also, except that in case of dividend here, the bond forwards are the bond forwards typically will have coupons. We will be dealing with them in the next slide, but just to draw similarities, there is not much of a difference between the equity forwards with the dividends and the bond forwards with coupons. But before we jump into that, we will also look at the equity index forwards. So equity index, as we said in this, wherever we talk about the index, we always try to bring in the continuous dividend yield rather than treating dividends on a discrete basis. So here the current value of the Nifty is 6,300. Continuous dividend yield is 4.7%, risk-free rate is 8%. So obviously my no arbitrage forward price S0 into e power r minus d into t. This is what is going to be the no arbitrage forward price on the Nifty index for 175 days. So that is what is going to be 6,300 into e to the power of 8% minus 4.7%, 8% minus 4.7% into t, 175 by 365, which is working out to 6,400.47. This is going to be the no arbitrage forward contract price, which means if both the parties enter into the equity index forward at 6,400.47, there is it's not going to create any kind of profit or loss to any one party on day 0. And now we are saying after 100 days the value of the Nifty has gone to 6,260. So so in case of this equity index forwards, if I want to find out the value, I'll take the spot price divided by e power dividend into the time to maturity. The time to maturity is we still have 75 days left, minus the present value of the forward. The present value, the forward is 6,400.47. I divide it by e power 8% into 75 by 365. This is what will bring me the value of the equity index forward after the contract is in force. So if I try to find out the value, it is nothing but 6,260 by e power 4.7% into 75 by 365 minus whatever is the no arbitrage forward price divided by e power 8% into 75 by 365. So which is working out that the value is minus 96.28, which means the long is losing 96.28 bucks, whereas the short is gaining 96.28 on this contract after the 100 days into the contract. So these are some of the ways we can try to understand the equity forward contracts and try to find out which party is at a benefit or which party is positive, which party is having a negative value position somewhere down the lane in the contract. And for all these things, when we are talking about the expiration or the maturity, I can always directly look at the spot price minus the forward price as the value to the long. Forward price minus the spot price is the value to the short, because there is nothing called present value on that day, because that is the expiration date or maturity date itself. So there is nothing called number of days to maturity in that kind of scenario. So that's where we directly take spot price minus the forward price. There is nothing called removing the present value of the future dividend, because there is nothing called future on that day, right? So that's one thing which we have to be comfortable with. Then, as I said earlier, when I have to look at fixed income security forward, treat it as equal as equity forward contract, where the dividend in the equity, you can look at it on the same lines as coupon in case of a bond. Rest all will remain the same, right? So if I just quickly look at the numerical, calculate the no arbitrage price on a 300-day forward on a 8.5% semi-annual coupon bond with a current price of 1027, whose next coupon is due in 150 days from now. So what is the coupon? 8.5% on 1000. So 85 is going to be the coupon, and because it's a semi-annual coupon, 42.5 is going to be the coupon. So adjusted spot price will be 1027 minus 42.5 by 1.08 to the power 150 by 365. This is the adjusted spot price. You multiply this by 1.08 to the power 300 by 365, which will give you the no arbitrage price of this forward contract. And the same way, if the spot price of the bond goes to 1010 after 150 days, 150 days means the coupon might have already been given, right? Because the coupon is due 150 days from now. So probably if the coupon is already given, so I don't need any of this adjustment now. So for finding out the value, I will take it as 1010 minus whatever is the forward price that I am getting divided by 1.08. 150 more days is there for maturity. So whatever is the forward price divided by 1.08 to the power 150 by 365 gives me the value to the long for this forward on the fixed income security. The negative of that will go as the value to the short position. So look at it exactly on the same lines as the equity forward. Wherever we were talking about dividend, there here we have to look at the coupon. Otherwise rest all is one and the same. Then in the next one we will look at the forward rate agreement. This is also a kind of a forward contract wherein we are fixing the interest rate on the loan. We are fixing the interest rate on a loan which is going to commence probably sometime later. So let's say today when I am getting into an FRA, which means let's say this FRA is a 2-month. The FRA is a 2-month FRA, which means I am fixing the interest rate for this date today only, because I am taking a loan here, let's say for 3 months. So if I am taking a loan for 3 months, after 2 months from now, probably the day on which I take the loan, the interest will be applicable as on that date. But by getting into an FRA, I am fixing the interest rate today itself as to what would be the applicable interest rate on the loan which I am going to take at this particular point for a 3-monthly period. So the payment of it actually happens on this date. So the real benefit will be realized on this date based on not this interest rate but the interest rate that is fixed as on this date. So that is what will give rise to the value of the FRA. So whenever we talk about the price, because every forward contract we said there will be a price element as well as the value element. So whenever we talk about the price, in this case we talk about that particular interest rate, which is a no arbitrage rate, which means whether as a lender or a borrower I get in, the value is 0 to either of the parties at the beginning or at the initiation of the contract. And of course, if at all I want to find out the value, probably I can find out the value as on this date, which means before the forward FRA got expired itself. If I want to find out the value of the position to the long or short, or even I can think of finding the value as on this date, which is the expiry or a maturity date of the FRA. So there are two different instances where I look at finding out the value. One within the period of FRA itself, and one on the maturity of FRA. So we will look at all these scenarios by a couple of examples which can simplify the understanding of each of these things. So the pricing as well as the value to the FRA is what we will consider. And as you may be knowing, whenever we talk about a notation, let's say 2/5 FRA, which means the FRA period is going to be for 2 months, just like this, or 2 periods, and the entire loan is going to end 5 periods from now, which means the loan is for a period of 3 months starting 2 months from now. That is what we call as a 2/5 FRA. Now let's try to understand the numericals behind it. Compute the no arbitrage rate for a 2/5 FRA. So I want to find out what should be the tied up interest rate for this date as on this date. For that, what we say is, okay, I'll go with a 60-day LIBOR, which is the investment from here to here, what is the rate, and a 150-day LIBOR. So based on these two, I will try to find out what should be this one. So basically it's like 1 plus whatever is the 60-day rate into 1 plus 60 to 150-day rate should be equal to 1 plus 150-day rate. This should be the context, which means if I want 1 plus 60 to 150, that is what is the FRA. So probably I can write it as 1 plus FRA rate should be equal to 1 plus 150-day rate divided by 1 plus 60-day rate. Right? So what is the 1 plus 150-day rate? 150-day LIBOR is 6%. So if I want, it becomes 1 plus 6% into 150 by 365. Right? 6% is an annual rate. For 150 days, I am going it by multiplying it as 150 by 365. So obviously this is coming out to 1.024. Same way, divided by 1 plus 60 day. So this is coming out as 1 plus, for a 60 day the LIBOR is 5%. 5% into 60 by 365. This is going to be the 1 plus 60 day rate. So between 2 and 5, it is nothing but 1.024 divided by 1.008. So 1 plus FRA is going to be this. So the FRA is going to be 1.63%. Right? The FRA is going to be 1.63%, and this is for only 90-day period. So I can very well annualize it or make it for 365 days by multiplying it by 365 by 90. So this is working out to 6.6 6.61%. So we are contracting at 6.61%. If at all we get into an agreement at 6.61%, then that is a no arbitrage contract price, which means neither the lender nor the borrower will have any big loss, especially if the interest rate is expected to be 6.61% for a 2/5 FRA, which means the loan, whatever you are planning to borrow after 2 months, you can fix the interest rate at 6.61%, going with these two values for the LIBOR at this moment. Now, going slightly deeper, if after 60 days from now, the 90-day interest rate has become 6.5%. After 60 days from now is on the day of expiry of FRA, we are finding that the actual interest rate is 6.5% for this loan, whereas we have contracted it at 6.61%. So the person who is borrowing is actually at a loss. The long in the case of FRA is the borrower, because the market price was only 6.5%, whereas the actual was 6.61%. This difference is for a 1 year, but we are talking about 90 days. So this is the difference for 90 days. So in terms of rupees or dollars, I multiply this by 1 million. The borrower is having a loss of this much on the FRA. So what is the loss to the borrower, if at all, on that day? The market price is 6.5%, the market rate is 6.5%, multiplied by the contracted rate, multiplied by the number of days of this loan into 1 million. If I am talking about 1 million, yes, I can put the numbers. So there is a loss of $276 to the long position or to the borrower. That loss is as on this date. So whenever I am talking about the value of the FRA, I have to find out the profit or loss as on this date, which means whatever is the amount that we have got minus 276.95, I have to discount it by 1 plus whatever is the 90-day rate, 6.5% into 90 by 365. This is what will give me the value of FRA on the maturity date itself. So to compute the value of the FRA on maturity, this divided by 1 plus 6.5% into 90 by 365. This is working out to minus 272.58. So minus 272.58 is the value to the lender, to the borrower, for getting into this FRA contract. Whereas when we look at it from a short position or from a lender's position, his position is going to be plus 272.58. That's one aspect. But instead of looking at it at the end, the other tricky part is I am not finding the value of the FRA on the expiry date, but I am trying to find it somewhere in the middle. So again, if I have to find it somewhere in the middle, I require this LIBOR as well as this LIBOR, and based on this, compute what should be the updated FRA, updated interest rate based on the new LIBORs. So take that as the actual market value. So in this case, this can be obtained as 1 plus 120-day rate divided by 1 plus 30-day rate. So what is the 120-day LIBOR is 5.7%. So this is working out as 1 plus 5.7% into 120 by 365. This is going to be the numerator, and denominator 30-day LIBOR is 4.8%. So this is coming out as 1 plus 4.8% into 30 by 365. So based on these two, I am getting the modified FRA rate to be this -1, and this number probably to be multiplied by this number to be multiplied by 365 by 90 to annualize it. So as per this, it is coming out that as per the changing interest rates, the FRA value should be around 5.98%, but the contracted is 6.861%. Now again, you can find out the value as on that date. You can very well find out the actual value minus the contracted value. This is for the 1 year, multiplied by 90 by 365, multiplied by 1 million. So this is going to be the loss to the long on the 150th day, on the day of payment of the loan. But I want to find out the value as on this date, which means I can discount it by 120 days at the rate of 120-day interest rate, which is the LIBOR for 120 days. So basically this divided by 1 plus 5.7% into 120 by 365. So if at all I want to find out the value somewhere in the middle, this is going to give me that the long is going to lose 1539.12. 1539.12 is going to be the loss for the long, whereas the negative of that is going to be the profit for the short. So we can, as far as the FRA is concerned, we can think of getting into, as far as the FRA is concerned, we can think of getting into the pricing of it, which is nothing but determining the fixed rate of interest as well as the value of it, and the value of it can be determined either on the maturity or expiration of the FRA, or somewhere during the period of FRA itself before the expiry period. Then the other set of forwards we are looking at in this session is the currency forward. Again, the typical way the currency is quoted is number of units of domestic currency per 1 unit of foreign currency. Right? Generally we say, okay, 60 rupees a dollar. If at all I am an Indian, I would be quoting that it is 60 rupees per dollar. So per 1 unit of foreign currency, I am trying to look at number of units of domestic currency. So in case of forward rate, the simple, again the no arbitrage pricing in case of currency forwards is, take this spot exchange rate and multiply it by 1 plus R domestic, which is the domestic risk-free rate of return, divided by the foreign risk-free rate of foreign currencies risk-free rate of return, and probably for the to the power t. There could be a continuous version of it also, wherein instead of 1 plus r, we take it as e power rd minus rf into t. Either of the ways, the difference may not be that significantly big. We can look at these things. So this is what will give me the foreign current. This is what will give me the forex forward contract based on the spot exchange rate. and this particular relationship is nothing but the interest rate parity relationship, which is based on the interest rate differentials between the two countries. So going with that numerical calculation, if the spot exchange rate is 60 rupees per dollar and the risk free rates in India and US are 8% and 5% respectively, find the 120-day forward contract. Probably if I am going with a discrete mechanism, I can say the forward is 60 into 1.08 by 1.05 to the power, because 1 plus RD by 1 plus RF to the power 120 by 365. So on a discrete mode, the spot price is going to be around 6. Spot rate, the forward rate on the exchange rate is going to be around 60.56. If I am going with a continuous mechanism, 60 into e to the power of RD minus RF, right, e to the power of RD minus RF into T into 120 by 365. So in a continuous base it is coming out to 60.59. Well, that may not be a very significant difference at all. So in general case, though you may get into a discrete mode, you could very well look out for a continuous mode also in terms of compounding and determining the no arbitrage forward price. The same way, if at all I have to do a value at certain point down the lane, you take the spot price, just like the example of a dividend, 1 plus divided by 1 plus RF to the power T minus the forward rate by 1 plus RD to the power T. The spot rate you discounted by the foreign currency rate or foreign countries risk-free rate of return, and the forward rate you discounted by domestic currencies risk-free rate of return to arrive at the forward value. So this is like this. If after 25 days the exchange rate is becoming 60.75, so what is the value? 60.75, you discount it by 1.05 to the power, this is 125 days into the contract, so 95 days are still left. So 60 by 1.05 to the power 95 by 365 minus whatever is the forward price, the forward rate, divided by 1.08 to the power 95 by 365. In this case, this is coming out to 0.62. So which means the long is going to gain 0.62 in this case, whereas the short is going to lose 0.62. Again, if we are talking about in terms of some $1 million worth of rupees or $1 million, whatever it is, we can convert them into an appropriate currency and then price, and then come out with the value in dollars or rupees as a benefit to the long or to the short. So this is how we will look at the currency forward transactions. So like this, on any forward contract, we can talk about the price as well as the value. Price is decided on the day we are entering into the contract, and the value is something that we are going to get as we move down the lane into the contract. And as far as this forward contracts are concerned, right, we have already discussed that these are more of personalized one-to-one kind of contracts. So there is a scope for huge credit risk because the counterparty may fail to pay on the settlement date. So wherever we are finding the value is large and positive, that party will be exposed to more and more of counterparty credit risk, because the chance that the other party will default will become very, very high in that context. So if the value is becoming more and more positive to a particular party, that party has to be more and more careful in terms of probably collecting a collateral from the other party or any other mechanism to make sure that the counterparty does not default in this process. Alright. So these are some of the basic calculation related steps that are involved in case of a forward contract. If you have any further queries on this, please feel free to get back to me on the number that I have given below, and you can even send in an email at vamsidhar@pacegurus.com. Thanks a lot for listening to this session. Thank you very much.